Hey, what's going on everyone, and welcome to episode number 15 of Everyday Python Projects. Today's project is a little different than my previous episodes since I'll be talking about the 10 best simple features of Pandas. To give a brief overview as to what Pandas is, it's a library that allows us to perform complex data analysis and manipulation with very few lines of code in a really efficient manner, which allows us to significantly improve our workflow. Alright, let's start. So the first thing I love about Pandas is how you can smash that like button. Make sure to import pandas and random. I'll be importing pandas as PD for the video. So number one is reading Excel files. Pandas allows us to read Excel files with multiple data types and easily convert a spreadsheet into a data frame in one easy step. You can do it like so. So test is a spreadsheet I made beforehand that has just some random data for us to parse through. So if we take a look at our data frame, we can see that there's a few different data types in this data frame. It looks like we have a floating point, strings, and integers. We can confirm this with the following code. So if I were to check the type of the 0th element in the 0th column of our data frame, we can see that it's a floating point, which is indeed correct. The 0th element of the first column is a string, and in the second column is an integer, which is confirmed right here. Without having to write any extra code, Pandas was able to infer the data types for each value in the spreadsheet. This makes it really easy to load lots of data with the variety of data types without having our data frame break. Number two, saving data frames to a CSV. So once we have a data frame, Pandas makes it ridiculously easy to convert this into a CSV in one line of code. So if we run this, we have now saved it to a CSV, and let's check our directory. And we can see that second test CSV is indeed here. Let's open it up. And we can see our data frame is here like so with our index and our headers and all of the data in between. If we decide that we don't want the index of the data frame nor the header, we can pass in the following arguments. Number three, value counts. Sometimes we'll have a data frame full of values and we want to be able to count the number of occurrences of each unique value within a column. This is extremely useful for data science applications or even e-commerce where you're trying to identify trends or patterns within your shop. For example, we can see there are a lot of colors in column 3. If we wanted to see how many colors there were, we can write this single line of code and execute it. So if we run this right here, it's very easy to see now. There are 16 occurrences of green, 12 occurrences of blue, and so on and so forth. So rather than having to write several for loops and keep track of the items by ourselves, Pandas can do this in fewer lines of code at a much faster speed. This is a really easy way to get a high-level overview of the data that we're dealing with. Number 4 is masks. If we want to filter our data, we need to pass in a mask. A mask allows us to apply certain conditions to our data so that we only view any data that meets these conditions. You can pass in almost any type of mask you want, so there are numerous ways to filter your data. Here's one example. Here, we want to see the entire data frame, and we only want to see the rows where the value in column 0 is greater than 0.6. Remember our original data frame with 51 rows. But if we were to run this, we can see that we now have a much smaller data frame, and all of the values within column 0 are indeed greater than 0.6. If we wanted to add multiple conditions in our mask, then we have to pass in each filter as a tuple like so. Here, we're once again looking for values in column 0 that are greater than 0.6, but now we also want to look for items in column 2 that are greater than 45. If we execute this, we have yet a smaller data frame, but it's easily observed that our conditions were met. This is extremely useful if you need to quickly parse through your data frame or retrieve key data that can be easily extracted with a few filters. Number 5, apply and Lambda functions. So apply is how Pandas can allow functions to perform some sort of operation on the data frame. One of the easiest ways to write a simple function is by using a Lambda function. So Lambda functions are anonymous functions that don't need to be declared with a name. You can just pass it in as an argument for cleaner and tighter code. So let's give ourselves an example. We have the following random words. I want to make a data frame that's 1,000 rows long and has one of the words in our list random words in each row. Not a problem, we can write this. This is just list comprehension, but all this basically says is to randomly generate a word from our list random words, append the newly generated word to a list, and then repeat this 1,000 times. In the event that we want to create a second column in df rand words, where each of those values will be the capitalized versions of column 1, we can achieve this with apply and a Lambda function. So here we're specifying that the first column, remember index 1, of df rand words will be calculated as follows. We're going to take the 0th column of df rand words and apply a function. In this function, x is the item in each row of df rand words. We then take x and call the upper method to capitalize this word. This is all done in the blink of an eye, and before you know it, the code has completely executed. So let's try it out. And check out df rand words, and you can see we have all of our words here, and some of them are lowercase, some of them are in title case. But if we were to run this and check df rand words again, now we can see the second column is equivalent to the first column. However, all of the strings are now capitalized. There's an infinite number of possibilities using apply and Lambda functions, so it's just up to you to manipulate the data in whatever way you see fit. Number 6, basic stats. Sometimes you just want some high-level stats on your data so that you can get an idea of what you're dealing with. Pandas can do this for you by providing the count, mean, standard deviation, minimum, maximum, and quartiles for any column that contains numerical values. We can do this like so. This code is about as short as it gets, but if we execute this, we can see that we do indeed get the aforementioned stats in a split second. Number 7, handling missing data. When you read data into a data frame, you won't have to worry about missing data, since Pandas will automatically fill in any blanks with a NaN, which stands for not a number. If we decided to delete some rows from our Excel file like so, by index, let's delete the 0th, 2nd, and 4th rows. Save this and close it. We can clear our console right here, and let's run this once again. We can see that we do have NaNs in each of the rows that we deleted from the spreadsheet. In the event that we want to replace the missing data, we have a few options. We can replace the missing data with the value of 0 like so. Fill na is fill the NA values, and we're passing in 0, which is what we're going to be filling in those values with. So if we run this, it returns a new data frame, and we can see in those rows that used to have NaN values are now just zeros across the board. We can also use a forward fill where missing data is replaced with the data in the same column, one row behind it. We use that same fill na method. However, in the method parameter, we specify forward fill. So let's look at df, where we have those empty rows, and then if we do a forward fill, you can see that the first row remains empty. That one makes sense, as there's nothing behind it to fill it in. However, the remaining rows, you can see row 2 should be empty, and it was filled with the values of row 1, like so. See how these are all duplicates? Same idea for row 4, it was filled with all the values from row 3. We can do the same thing, but in the opposite direction, using a backwards fill, where missing data is replaced with the data in the same column, but one row in front of it. All we did is change the method from ffill to bfill, and now we can see this empty row that we have right here was filled in with the information from row 1, and row 2 was filled in with the data from row 3, and row 4 was filled in with the data from row 5. Number 8, concatenating and merging data frames. So what is concatenation? Think of it as stacking 2 or more data frames together, either vertically or horizontally. The dimensions don't have to be the same for the data frames. And in an outer fill, which means you combine all data from the data frames, the new data frame will have NaN values anywhere where the dimensions of the 2 data frames didn't match. So let's use the following data. Here we have a 10 by 10 data frame of numbers and a 2 by 10 data frame of words. Let's execute this to actually see these data frames. So df numbers looks like so. Our 10 by 10 data frame, and test looks like so with our 2 by 10 data frame of just words. If we wanted to stack these data frames horizontally, we can do it like so. If we execute this, so you can see that the words data frame was basically stitched to the side of the numbers data frame. That's because we specified an axis of 1, which means go along the columns of the data frame. All these NaN values are here because we specified the method for join to be outer, which means include all the data from both data frames and put a NaN for missing data. If we said it should be an inner join, we can see that all of those NaN values are gone because it's only returning rows with complete data. If we wanted to do this vertically and for an outer join, we just have to change the axis from 1 to 0 and change the join to outer. Now, the words data frame is stitched to the bottom of the numbers data frame, but remember that what we have is a brand new data frame. Neither of the original data frames have been manipulated. In this case, because we don't have any NaN values, there won't be a difference if we choose inner or outer for the join, since no rows or columns will be excluded. So that covers the basics of concatenation, but what about merging? Merging is like concatenation, but it's done on the basis of a common column on the data frames that you want to merge. So let's say we have data like this. First, let's see what this looks like. So in these data frames, we can see that key is the common column. So if we write something like this, let's see what we get. Okay, this looks a little confusing, but we can piece this together. In df1, we have 3 instances of the key B, here, here, and here. And in df2, we also have 3 instances of the key B, here, here, and here. When we merged, we're using the column key since it's the common column among the data frames, and it's going to find all combinations of keys between df1 and df2. So for merge, order does matter. We're starting with df1 and merging df2 onto it. So we can see here, let's look at all of these B values. We have B0, 1, and where does that come from? Well, we have B and 0, and we need to match up all the combinations. So if we start with B0 in df1, then look at the first value of B in df2. Right here, under data 2, it says 1. So that's where B01 came from. Next, it says B04. That makes sense. B0 is going to be matched up with B4, which is why we have B04, and so on and so forth for B05. This is going to work its way down the list until we get all combinations. That's why after the B0 set, we have B6, 1 right here, because B6 in DF1 is the next key and data pair, and we need to find all of the combinations between this in DF1 and all the B values in DF2. This will happen for the remaining letters, which is why we get this data frame. Number 9, grouping items within data frames. So remember our original data frame DF? Let's call it up again. The method groupBy allows us to literally group a column by its values and then perform some sort of operation on the entire data frame. So if we wrote something like this, then what we're saying is we're going to group this data frame by the values in column 3, which is all of this right here. They're the various colors in this data frame. And once this is grouped, we have to do something to it. Here, we're going to be taking the mean. So let's use the color blue as an example. It's going to retrieve each of the rows in the data frame where blue appears in column 3. It will then find the mean of those values per column and return it to us. It'll do this for each of the values in column 3 and return the results like so. So we can see that for blue, the mean value in column 0 is 0.55. If we scroll back up top, this means we took 0.314862, 0.134709, 0.889195, so on and so forth, all the way down column 0 and calculated the average value. We did the same thing in column 2 and continued doing this for each color. So groupBy is a very fast way to get some high-level data in our data frame without having to write several lines of code to do this for us and risk making an error with our calculations. So this last one is sort of a bonus, but it is a core principle of Pandas. So Pandas was written in Python, C, and Cython, which is a combination of C and Python code. Long story short, properly written C code is just about as fast as it gets, and the code within Pandas has been optimized quite extensively over the past several years. It won't be as fast as running native C on your machine, as there's some intermediate steps that have to take place in order for this to function within Python. And each of those steps, however small they might be, take a little bit of time, so it does start to add up. However, it's a significant upgrade than trying to perform all of these operations using only pure Python. So learning how to use Pandas is extremely beneficial since it speeds up basically anything you'd be writing in pure Python, which is really important once you start using larger and larger datasets. That's it for this video. If you enjoyed it, please hit that like button and subscribe for more video tutorials. I think I finally found my groove of doing 3 of these videos a week, as 5 was like a really lofty goal to try and accomplish, especially because I have a full-time job that takes up a ton of my free time. But hopefully in the future I'll have a bit more time available so I can start outputting a few more videos per week. Otherwise, I will see you in the next one.